Hi everyone. In my today's session, I'm going to explain about the change of responsibility design pattern, which is basically falling into our behavioral design patterns category. So let's start with it. So let's start with what problems can the chain of responsibility design pattern solve? Okay. So coupling the sender of a request to its receiver should be avoided. Okay. So suppose there is a setup where there is a sender of a request and there is a receiver of a request who basically process the request. So we should decouple the sender as well as the receiver of a request. Okay, they should be independent of each other, and then it should be possible that more than one receiver can handle a request. Okay, so instead of having only one receiver for one particular request, we can give an option of multiple receivers. Okay, so whoever is capable of solving that request, right, that request object can solve the problem or the request or satisfy the request basically, or fulfill the request, you would say. Implementing a request directly within the class that sends the request is inflexible because it couples the class to a particular receiver and makes it impossible to support multiple receivers. Okay, so that is the one biggest drawback if we couple the request of the the sender of the request as well as the receiver basically. Okay, so that's what the chain of responsibility design pattern tries to solve this problem over here. So what solution does the chain of responsibility design pattern describe? Define a chain of receiver objects having the responsibility, depending on runtime conditions, to either handle a request or forward it to the next receiver on the chain if there are any. Okay, so you got it right. So instead of coupling the sender of a request as well as a receiver together, what we do, we define a chain of receiver objects having some responsibility to fulfill the request, okay, depending on some runtime conditions, to either handle that request or forward it to the next receiver, okay, in the chain basically. So this enables us to send a request to a chain of receivers without having to know which one handles the request. Okay. So you have multiple options and you don't know which will handle the request. Okay. So you are basically the sender is decoupled from all the receivers. The request gets passed along the chain until the receivers handles the request. The sender of a request is no longer coupled to a particular receiver. Okay. So this is the solution the chain of responsibility pattern provides. Okay. I'm going to show you how that setup will be done from the code side or in the UML diagram basically. Okay, so each handler basically contains a reference to the next handler in the chain. Okay, so this is how basically this particular solution of chain of responsibility is achieved. Okay, so let's go through now what is the chain of responsibility design pattern. Okay, so the chain of responsibility design pattern avoids coupling of the sender of a request to its receiver by giving more than one object a chance to handle the request, as already explained. This pattern chains the receiving objects and passes the request along the chain until an object handles it. Okay, a mechanism also exists for adding new receiving objects to the end of the chain. See the flexibility, guys. Okay, so you can create on the fly receiver or the handler objects, okay, and attach it to the chain. Okay, so if you find out that for a particular request or a particular kind of problem, if you have more than one solution or more than one handler is available, okay, in such case you can create such new handler objects or handler concrete classes, and you can basically attach it at the end of the chain so that you get some more options or chances to handle the request object. The chain of responsibility pattern is structurally nearly identical to the decorator pattern, guys. Okay, I agree with it because a decorator adds additional behavior to an object at the runtime, and what chain of responsibility is doing, that is also doing the same thing. That is also adding some additional, that is also trying to solve a problem at the runtime based on some conditions with multiple options. Okay, so the chain of responsibility pattern is structurally nearly identical to the decorator pattern, but the difference being that for a decorator, all classes handle the request. So in case of decorator, okay, whatever decorators you keep on adding to a object, right, for a runtime object. So each and every decorator class adds some additional behavior for that object. But when it comes to our chain of responsibility, okay, few of the classes or all of the classes can handle the request or try to process the request, okay, or add some behavior basically. So here, always not all classes will provide some processing for your incoming request. Only few, sometimes it may be one, two, or all of the classes may try to handle the request. So that is the slight difference, okay. So the UML class diagram, okay, let's go through this now. Sender is basically a client program or your main program, okay. So handler is a abstract base class, or you can implement using an interface also, okay. So I would recommend abstract base class over here. So it should contain a method called handle request. Very simple, handle request, and you pass the request inside that object, okay, inside this method, sorry, okay. And also this handler abstract base class also contains a reference to the next handler by holding a reference variable of its own class, which is called successor, or you would say next handler. And then you provide a concrete implementation for your receiver objects, okay. For this handler, you provide the concrete implementation for this handler object, like receiver 1 or handler 1, handler 2, handler 3, like that, receiver 1, 2, 3, okay. So each receiver handles the request in its own way, okay, and it will check whether it can handle or not. If it can handle, it will handles it and returns the result, okay. Otherwise, if it can't handle, if it can handle some part of it, and if it is not able to handle, if it is not able to handle some part of it, then it will forward that request to the next handler in the chain or next receiver in the chain, okay. I will go through the cons later, so let's see the program first. So this is the setup I have done, a very trivial program, okay, which basically involves the approval logic, okay. You are doing some procurement, you are doing a procurement of some software. So for this procurement of this software products, so what I'm doing is basically who can approve it. Either a director can approve it, okay, either a vice president can approve it, or a president can approve it, but based on some condition. And what are those conditions, I'm going to explain. So first of all, I should have an abstract base class called approver, okay. This is my handler now. It's abstraction on our handler as per UML class diagram. So protected approver, next approver. See, I am containing, basically I'm containing a reference variable of the handler class itself, which is approver. So next approver, and then public void set successor. Okay, a method to set the next successor. So in order to set this next approver, okay. So if this particular class or a concrete class is not able to handle this request, it should forward the request to next approver, right? So that next approver will be set by using set accessor method. And then one abstract method, okay, a pure abstract method which doesn't contain any implementation in the abstract base class, which is called process request, and you pass the request object to that, okay. So this is the base class setup. Now let's start with the concrete implementation. So who are the various approvers? We have director, vice president, and then president. So director class inherits from approver, that is basically a handler, okay. So inherits from the approver class, approver base class. Then he overrides the method process request and passes the procurement request basically, okay. So here what happens is, if the purchase amount is less than 2 lakh rupees, okay, if the purchase amount is less than 2 lakh rupees, then director can approve this procurement or purchase, you would say, okay. If it is not less than 2 lakh rupees, if it is more than 2 lakh rupees, then I will call the next approver, okay. So where is the next approver available? It is available from the base class itself. I know who is the next approver. So what I do, next approver dot process request, I will just forward that request, okay. Again, same for the vice president. His condition is, if it is less than 3 lakhs, he will process, otherwise he will forward it to next approver. So president is the final one, the final person who is going to approve. So if it is less than 7 lakhs, he will approve, otherwise what he does, he basically requires an executive meeting, okay. This is the end of chain basically. So this is my procurement class, and let's see the setup of chain now. First, we have to create the handler objects or the approver objects. So approver L1, approver L2, approver L3. Okay. then we need to set up the chain now. L1 dot set successor L2. If L1 is not able to process the request, then who should be? It should be L2, which is vice president. Okay. If L2 is not able to process the request, then who should be the approver? President. Okay. And then I will create a request procurement. Okay. Some product, Visual Studio Enterprise Edition. Okay. With price being 3,50,000, and then I will call L1 dot process request on the first object in the chain, okay, which is the L1. I will start with the director first. Okay. Same for the another product, Microsoft Visio, to create design documents, okay, which is of 25,000 rupees in cost. And one more product, one more is the project. Basically we are developing a software project, and for that project basically we need this much amount, which is 4 lakhs, a trivial example. And then we will start with the approval process or processing the request. Okay. So if I run the program, see, president approved request 200. Okay. If I go to the request 200, okay, which one? This one. This is 3 lakh 50,000 rupees. So can my director approve this? See, a director's limit is less than 2 lakh rupees. So he won't. That's why what happened? It's 3 lakh 50,000. So vice president also can't approve it because it is greater than 3 lakh rupees. So president will approve that amount because he can approve amount less than 7 lakh rupees. Okay. So like this, it went through the chain. Okay. Inside of the chain, it went through each and every handler basically. Okay. And finally it approved it. Okay. If I put one more amount over here, which is more than 7 lakhs, then you will get the output of this one over here. Okay. Even the president can't approve that, and he will require a meeting, an executive meeting, to whether procure that particular software product or not, or any kind of product or not. So very simple setup. I hope you people understood how it works, the chain of responsibility pattern. All these things are your concrete approvers, whereas your approver is the abstract base class approver, which contains the next approver or the next handler, reference to next handler, and also the set accessor methods. Okay. And then the process request method. Okay. And then the concrete handlers, and then your client program will basically create the handler objects. Okay. And then they will set up the chain. Okay. L1 dot set successor L2 and L2 dot set successor L3, like this. And then we call L1 dot process request for each and every object. So it should start from the L1, from the director, and then we will see who can approve based on the amount over here. Okay, so let's go through the cons now. What are the cons associated with this pattern? Sometimes it will be difficult to observe the runtime characteristics and remove errors. Yes, sometimes it will be difficult because the runtime characteristics may change based on the data you are passing through your the chain. Okay, the chain of responsibility, or the chain of handlers basically. Okay. And you should be very sure about your request data or the data you are passing to your chain basically. Okay. So if you want to debug it properly, you should know the data properly. Okay. Only you can, then only you can understand which handler basically failed. Okay. So let's understand one more scenario. Sometimes it will be difficult to observe the runtime characteristics and remove errors. So while processing something, let's take an example of this itself. Okay. Suppose this involves very a complex logic over here to provide the approval. Okay. From the president side or the director side or from the vice president side. Now, while performing that business logic, if due to the invalid value coming from this request, okay, so your this particular process request method thrown an application exception. Just imagine a scenario. Okay. So due to some invalid value in your procurement object, it thrown an exception. So what will happen? Okay, it will become very difficult. So you have to go through your stack trace, you have to identify for what value it basically failed. So you should know you the request snapshot you are passing basically. Okay. And sometimes this chain of responsibility design pattern can get broken easily. So that's what the example I give. While processing the request, due to some reason, invalid input data, or because of some resources were not available, okay, some network resources or API resources were not available, due to that, suppose your process request method throws an exception, in that case your chain will be broken. Okay. So you should have a mechanism. What kind of mechanism you will have? You have to once again fire the request. Okay. So basically your sender should once again fire the request. So you have to notify the sender that this got failed and the request should try once again after some time so that he can get the responses. So the request can get dropped if a handler was unsuccessful to call the next handler due to exceptions. So whenever some exception takes place, right, your program will be exited basically. Okay, your program, if you are handling except if you are doing a proper exception handling, okay, what happens, you go to your exception block and you will come out of your program, because when your current handler itself was not able to process it properly, right, the request, then there is no point in calling the next handler from your catch block. Okay, so what happens, you have to simply get out of that method itself. Okay, so that is the issue basically. You won't be able to successfully call the next handler due to exceptions. And if one handler calls the incorrect handler, it can harm the entire chain. So suppose there is a scenario, if you are building the chain of your chain of responsibilities dynamically based on some configuration which is coming from a configuration file or a database, and due to some reason if somebody played with that configuration and made a mistake while setting up that configuration, right, you will end up with harming the entire chain itself. So these are some things we have to take care of when we are dealing with this chain of responsibility design pattern. But apart from that, if you take care properly with these points, I think this is the best solution basically when you want to decouple your sender as well as the receiver from the processing logic. Okay, whenever your request needs to be processed. Okay, and when you want to provide multiple chances of processing that request. Okay, so that's all from my side, and thank you for listening, guys, and have a nice day.